name's Jose Lopez. I'm part of Group 6, and I'll be presenting problem 2. For a particular cell, the concentration in sucrose is 10 micromoles on the inside of the cell and 0.5 micromoles on the outside, whereas the concentration of the sodium ions is 0.5 micromoles on the inside of the cell and 10 micromoles on the outside. The membrane potential is negative 150 millivolts, and the temperature is 25 degrees Celsius. First question, what is the delta G for the inward transport of sucrose? Before we do that, let's identify each variable. So R is 1.987 calories per mole. T is for temperature, that is 25 degrees Celsius. However, it needs to be calculated in Kelvin. So to convert Celsius into Kelvin, you add 25 plus 273, you get 298. Ln, that's a logarithmic function. S in is the concentration inside the cell. S out is the concentration of the molecule outside of the cell. And then Z is the charge of whatever molecule we're dealing with. F is another constant, 23062, and V is for volts. In this instance, it would be negative 150 millivolts. You do, however, would want to convert this to regular volts, so instead of negative 150 millivolts, it'd be negative 0.150. So let's plug in our numbers. R, 1.987, T, 298, times the logarithm function of 10 millimoles over 0.5 millimoles. Since the concentration on the inside is greater than the outside, the final answer will be positive. If there's ever an instance where you do the math and you get a negative number, check your math again because, it could be incorrect. So since sucrose does not have a charge, the charge is 0, as you can see. And if one number is 0, the whole thing is 0. However, you can see, let's say if you did do the math, it's 0 times 23062 times negative 150 times 10 to the negative third. So the final answer is 1.774 kilocalories per mole. When you do get the final answer, it does not come to you as kilocalories, it'll come to you as calories. So originally it was 1,774 calories converted to kilocalories. Question B, what is the delta G for the inward transport of sodium? So it's very similar to the first part. However, sodium has a charge, and another difference is that the concentration outside of the cell is greater than the inside. It just so happens that the numbers are the exact same thing, just swapped. So you could quite literally just grab this number and input it for this initial part. However, it would be negative because, again, the concentration inside is lower than the outside. So now that sodium has a charge, you can add Z is 1, you can tell because there's that one charge. So 1 times 23.62 calories per mole times negative 150 volts. You add those, the first half and the second half together, and you get negative 1.685 kilocalories per mole. Part C, which is probably the easiest part of the problem, all you have to do is add question A and question B, and the total is 0.089 kilocalories per mole. Thank you.